This is no gemstone. It's a living creature. For decades, the light from this tiny snail baffled scientists, seeming to break the known rules of bioluminescence. And its secret is launching a brand new journey into the deep, to unravel the stories we've been told about glowing animals and expose the shocking truths behind how, and why, they make their own light. The ocean's deep zones are a world of absolute darkness, a place sunlight has never touched. Go deeper than about 200 meters, and the sea is plunged into perpetual night. And yet, it's not dark. It's filled with living light. A silent, secret language spoken in pulses of blue, green, and even red. This is bioluminescence. While it's a rarity on land, in the vast, three-dimensional world of the ocean, it's the rule, not the exception. Current estimates suggest that about 3/4 of all undersea animals can produce their own light. This isn't just some random party trick, it's a fundamental tool for survival, a phenomenon that has evolved independently at least 94 times across the history of life. And the story of how life learned to glow is far older and stranger than we ever imagined. But if we're going to understand it, we have to start with that tiny, rule-breaking snail. On the rocky shores of Australia and New Zealand lives a small sea snail called the yellow-coated clusterwink, or Hinia brasiliana. Like any snail, it has a hard, protective shell. But this one's hiding something special. When a predator comes too close, say, a curious crab, it doesn't just pull back into its shell. It puts on a brilliant light show. From deep within its body, flashes of dazzling green light erupt. For a long time, scientists were stumped. For one, bioluminescence in bottom-dwelling snails is incredibly rare. But the real head-scratcher was the shell itself. It's opaque and yellowish, the kind of material that should block or at least dim any light. So how was this snail putting on such a vibrant display? Researchers Dimitri Dehaene and Narita Wilson decided to find out. They discovered the light comes from two small patches of cells hidden on the snail's body, safe inside the shell. What happens next is an act of biological genius. That shell, which looks like a barrier, is actually a highly advanced piece of optical equipment. It acts as a perfect light diffuser, but only for the specific blue-green wavelength of the snail's own light. It captures the glow from those two tiny points and scatters it evenly across its entire surface, making the whole shell shine. This is an amazing trick because it creates the illusion of a much larger, luminous creature, startling predators and giving the snail a chance to live another day. The snail's shell is a custom-built lampshade, a piece of natural technology that outperforms many commercially engineered diffusers. This snail opened up a whole new principle. Bioluminescence isn't just about making light, it can also be about manipulating it. It's a case of coevolution. The living light and the shell it shines through are evolving in perfect sync. But to really appreciate just how radical that is, we have to travel into the deep and see the extreme ways other animals use their inner glow. Light is power in the crushing pressure and total blackness of the deep ocean. And for many, it's the ultimate defensive weapon. When you can't see a threat coming, the next best thing to do is to turn yourself into a living flashbang. Take the burglar alarm strategy, perfected by creatures like jellyfish. When a jellyfish is under attack by a small predator, it can't always fight back. So instead, it lights up, flashing brilliantly in the dark. This flash doesn't hurt the attacker but does something way more clever: it attracts bigger, meaner predators. The flash is a scream for help that says, "Hey, there's a commotion over here." A larger fish might then swoop in to eat the small predator, accidentally saving the jellyfish. But no creature has mastered defensive light quite like the vampire squid. Its scientific name, Vampiroteuthis infernalis, means vampire squid from hell, but its strategy is more about dazzling than draining. When threatened, the vampire squid pulls its webbed arms up and over its body, exposing harmless spines in a defensive stance called the pineapple pose. If that doesn't work, it escalates. Instead of ink, it blasts a sticky cloud of glowing mucus from its arm tips. This cloud, filled with countless orbs of blue light, can glow for up to 10 minutes, creating a confusing sparkling mess that blinds and distracts a predator while the squid vanishes into the black. The attacker is left covered in a glowing slime, making it a bright shining target for its own predators. While some animals use light to escape, others use it to kill. In the endless dark, a single point of light is an irresistible curiosity. And the most famous predator to exploit this is the deep-sea anglerfish. She is pure nightmare fuel, a cavernous mouth full of needle-like teeth. But her real weapon is the fishing rod-like spine growing from her head, which ends in a fleshy ball called an esca. This esca isn't lit by the anglerfish herself. Instead, it's a living apartment complex for glowing bacteria. She gives them a safe home and nutrients, and in return, they produce a constant, mesmerizing glow. This symbiotic lure dangles in the darkness, attracting smaller fish and crustaceans that think they've found a meal. When they get close enough to investigate that lonely light, the anglerfish's massive jaws snap shut. Trap sprung. It's a flawless hunting strategy in a world with nowhere to hide. Other hunters have taken this a step further. The stoplight loose jaw, a type of dragonfish, has developed its own biological night vision. Most light in the deep sea is blue, since it's the color that travels farthest through water. Because of this, many deep-sea animals have evolved to be red, a color that makes them practically invisible because there's no red light to reflect. The loose jaw, however, has two sets of lights under its eyes. One produces green light, but the other produces red light, acting like a sniper's scope. It can light up its red-colored prey, which can't see the red light, allowing the loose jaw to hunt in complete stealth. It sees them, but they can't see it coming. It's a profound evolutionary arms race, fought with photons. Perhaps the most complex use of bioluminescence can be seen in its use for communication. On land, we see this in the blinking conversations of fireflies. But in the ocean, these chats are even more spectacular. Tiny crustaceans called ostracods, or sea fireflies, are the masters of this. Each night, about an hour after sunset, the males gather to put on a show for the females. In what's been called one of the most complex courtship displays in the marine world, each male swims in a precise, spiraling upward pattern, squirting pulses of glowing mucus to create intricate trails of light. Each species has its own unique light dance, a specific pattern of flashes, pauses, and movements. Females watch from below, judging the males on the complexity and precision of their luminous choreography. When hundreds of males display at once, they create cascading waves of light that ripple across the seafloor, a silent, synchronized fireworks show designed for a single purpose: finding a mate. This use of light as a language, as a signature, and as a work of art shows just how deeply bioluminescence is interwoven into the fabric of ocean life, not just to hunt or hide, but to connect. From snails that turn their own shells into lanterns to squid that paint the dark with glowing ink, living light is far stranger and more versatile than we ever knew. It's a story of burglar alarms, secret sniper scopes, and silent symphonies. And just when we thought we had the timeline figured out, a new discovery rewrote the whole story. For decades, the oldest known example of bioluminescence was thought to have appeared 267 million years ago in ancient crustaceans called ostracods. But stunning research from 2024 has absolutely shattered that record. By analyzing the genetics of soft corals, scientists found evidence that their ancestors, and the common ancestor of all octocorals, were already lighting up the ocean 540 million years ago. This pushes the origin of animal light back almost 300 million years, placing it right in the middle of the Cambrian explosion, the moment complex animal life first exploded in diversity. It suggests that light signaling may have been one of the very first forms of communication on Earth, evolving in lockstep with the very first eyes that could see it. The deep sea is the largest living space on our planet, and we know more about the surface of the moon. Every dive and every discovery shows us that our book of knowledge is missing whole sections of chapters. And the story of bioluminescence is a powerful reminder that even in total darkness, there's still so much to be discovered, to be finally brought to light. A small snail that can defeat decades of science. 500 million years ago, in an unimaginable world, life was already able to conquer darkness by making its own light. If you were fascinated by the mysteries of living light, make sure to subscribe and hit that notification bell so you don't miss our next journey into the unknown. And in the comments, let us know, which glowing creature do you find the most amazing?